I wish this video was sponsored by TOP, but I bought it with my own money. Anyway, so 1.9, this was not part of our test because I felt like it would be too much if I included that into our chapter 1 test. So I left it aside. But actually graphing and solving quadratic inequalities is not challenging at all. So I am looking at our questions from Workbook 1.9, and the very first question says, determine whether the ordered pair is a solution of the inequality. So in order for us to determine if 1, 6 is a solution for this inequality, we simply have to substitute x and y value that's given to us into our original inequality statement, and if this inequality is true or nah. Okay, so let's see. 6, 1 square plus 2, 1, 2. So I have 1 square plus 2 times 1 plus 2. And what I end up getting is 1 plus 2 plus 2. And 1 plus 2 plus 2 happens to be 5. So this statement, 6 is certainly not smaller than 5. So therefore, it isn't. So no, I just simply put a cross right over there. Let's try number 3. Y is smaller than or equal to 2x squared minus 7x, and the given coordinate point is 4, 4. This is number 3. So again, we substitute the given value into our inequality statement. So what I end up getting is 4 is smaller than or equal to 2 times 4 squared, so that'll be 32, minus 7 times 4. And it gets simplified to this statement right here. 4 is indeed bigger than or equal to 4. So because of that equality sign below, this statement is true. So 4, 4 is a solution. 4 is solution. All right, so this was sort of like a little warm-up. And now we're going to go into actually graphing our inequality. So here are a couple of steps you can take. First, I'm going to go ahead and take a look at number 8. All right. Number 8 is y is bigger than or equal to x squared minus 2. This is what I have. The very first step is we're going to pretend like instead of inequality sign, we just have an equal sign. Step 1. Step 1, y equals x squared minus 2. That's my step 1. Step 1, y equals x squared minus 2. Okay. And then step 2, we're going to graph it. And this is what I have. This is my graph, right? After I graph it, now step 3. We're going to go back to our original inequality statement, and it's, you can see we want our y to be bigger than or equal to x squared minus 2. So since we have equal sign, all of these values, because the values that are on the parabola actually is this, right? So we assume that y values are all equal to x squared minus 2. So this, by leaving this as a solid line, we are saying, hey, all the values on the parabola are solution to this inequality statement, original inequality statement. And now what we're going to do is we're going to we're going to pretend like this parabola line is our border, and we're going to pretend like we can pick any point on over here from this region, or any point from below the parabola. Or I shouldn't say below, I guess I would say outside. So pick a point either inside of the parabola or outside of the parabola. And for me, I'm gonna pick outside. So I'm gonna pick 3. No, actually, I'm gonna pick inside 0, 0. Okay. So if I do let y equals 0, x equals 0, okay? Let y equal to 0, x equal to 0, and then what do I get? 0 is bigger than or equal to, so step 4 is 0 is equal to or bigger than 0 minus 2. So 0 minus 2. And this statement, is it true or false? This statement is true. So therefore, all the values, remember I picked 0, 0, which is inside of the parabola, right? So all the values inside of the parabola are solution to this inequality statement. Okay, let's do another one. Number 9. Y is smaller than negative x squared minus 2x plus 1. So step 1. Step 1. Pretend like our inequality statement is an equality statement. Y equals negative x squared minus 2x plus 1. Step 2. Graph above step 2. So step 1, pretend like we have an equality sign. Step 2, graph it. But over here we said y is actually smaller, right? So all the values that are on the parabola, technically this doesn't make sense. This is not what the inequality statement is asking us, correct? So therefore, we, instead of leaving our parabola like in solid line, instead we leave it as a dashed line. So and negative b over 2a. So I'm going to use vertex. That would be positive 2 over negative 2, negative 1. So when x is negative 1, it would be negative 1, positive 2. So positive 1 plus 2. That's my vertex. So, like I said, instead of creating a solid line, we create a dashed line to indicate that the points on the parabola, all the points on the parabola are not included in this inequality statement. So this is what I have. I used a dashed line. And then step 3, we go ahead, pick a value either inside. Hi, Lucas. Bye, Lucas. Hey, don't hit your mouse.
Thank you. Sorry.
It's okay. Inside of the parabola or outside of the parabola. So I'm going to go ahead, pick inside of the parabola again. So -1. X equals -1, y equals 0. That's the point that I pick. -1, 0. And then we go ahead, substitute that. Step 4. So 0 is smaller than or equal to -1. So that would be -1 squared. It would be +1, -1 plus 2 plus 1. So 2. Right? Yes, and 0 is indeed smaller than 2. So under inside of the parabola, all the points inside of the parabola, are all true to this inequality statement. So I'm going to go ahead, shade all the points underneath right here. Let's try number 10. Y is smaller than or equal to x squared minus 3x plus 15. So step 1, pretend like we just have an equation. Y equals x squared minus 3x plus 15. Step 2, graph it. And since we have an equal sign, that means all the points on the parabola establish this inequality statement to be true. So we need to have a solid line, or solid parabola, I should say. So we have 15. Again, use vertex. So positive b over 2a, 9 over 2. And if we substitute that, we get 80 square minus 3, 9 over 2 plus 15. So that's going to be 81 over 4 minus 27 over 2 plus 15. So that'll be 81 minus 54. So 81 minus 54. So that would be 27 over 4 plus 15. So that's going to be 21.75. So when x is 4.5, 1, 2, 3, 4, 4.5, y is 21 over, okay, something like that. Oh, yes. So what I end up having, 9 over 2, 2a. Why did I just square it? Oh. So we first find our vertex. So it would be positive 3 over 2. And we substitute that into our equation. So we get y equals 9 over 4 minus 9 over 2 plus 15. So we get negative 9 over 4 plus 15. So that's going to be 51 over 4. So 12.75, around 12.75. So 4.5 would be 12.75. And we are going to have a solid parabola. My parabola looks really weird, but this is the parabola that we have over here. And now we pick a point, random point, either inside or outside of the parabola. I'm gonna just choose a 0, 0, which is outside of the parabola. So 0 is smaller than or equal to 0 minus 0 square minus 0 plus 15. So then we get 15. And this statement is true, so therefore all the points 0, 0 is sitting outside of the parabola, right? So all the points outside of the parabola are true to the inequality statement. So I go ahead and shade that part. Don't worry about this. This was a mistake. Now, so I want you to go ahead and try